In this video, we are going to learn about one of the very important function is called the quadratic function. So, which is the degree 2 polynomial. A quadratic function has the form. So, quadratic function has the form let's say fx equal a x squared plus bx plus c. The only assumption is a not equal to 0, because if a equals 0, it is not quadratic anymore. Now the question is why this is important. So we have this very important question, why this is important. So you may have seen a situation where the diver jump from a platform. So if you diver jump from a platform, and then if you try to let's say you're going to plot the height versus the time. So that means you're going to put the time on this axis and the height from that axis. So let's say the jump, so we can start at 0. So maybe this is the height the diver jump off, and then you can see if you let's say measure the time at every second. So you might see go off a little and then go down like that. So what happens if you look at the actual path, if you just connect the dots and if you see the complete path, so you may see something like this. So go like that and then gonna go through these points. So you will get something like that. So you can see that this is not random. So they are a special situation. This graph has a special shape. So these kind of graphs are what we normally call the parabola. So parabola. So when you have a parabola, so this function has a special shape. For example, if you actually find this function using mathematics, you end up getting something like this. There's some constant. In this case, if you use the t variable, so let's change this. So if you use the t variable, so it's going to be a t squared plus bt plus c. So you're going to get this type of equation. Actually, this is not x, this is t, variable t. So you can see that this is a quadratic function. So these kind of functions appear every time in the nature. There are many other situations, like for example, you throw a stone up, and if you again measure the height, you can see that height gonna follow a parabola. And then also if you look at the sometimes the profit function, like let's say you have a company, you need to find what is the profit. They also kind of follow parabolic equations. So that means there's a maximum value. And also, like there are a lot of other similar situations, like if you want to find the path of a golf ball, once it's kicked by a bat, and you can see it can follow a parabolic curve. So that means this is very important. And then what we're going to do in this lecture, we're going to learn about the properties of that. So before that, let's recall some of the things that we learned in the previous video. So that's about the quadratic equation. So we have the quadratic equation. So we talk about four methods. So what's the quadratic equation? If you set the quadratic function, equal to 0, again a not equal to 0. So this is what we call the quadratic equation, because it's an equation. And then the question is how to solve. So we talk about four methods. Let's listen. So you can see the first one is, or most common one, is the factoring. So we talk about factoring method. Factoring method. So for example, if you have a problem like this, let's say x squared minus 3x minus 28 equals 0. So this is a kind of problem that you can see it's easy to factor. So we're gonna go for the factoring method. If it is easy to factor, go for the factoring method. So the second one is what we call the square root method. Square root method. So square root method applies to special type of problems. For example, you're going to see x plus some number squared minus 17, something like that. So you can see that there's a square root is square here. So we're going to do the square root method for this kind of problems. And then the third type is the completing square method. So completing square method, completing square method. So in the completing square method, what we're gonna do, so this is like one of the very important technique. So for example, let's say you have a problem like this. So 2x squared minus 3x minus 7 equals 0. So we use the completing square when it is hard to factor. When it is hard to factor or it is not in the square root format, there's no square in there, so then we use the completing square method or complete the square method for those kind of problems. And if you don't know any of them, there are separate video for each of them, and you can watch them, and you can find the link in the description. So and then also we normally use as the last resort, we talk about the quadratic formula technique. So so that's the last one, the quadratic formula. So quadratic formula. Um, so this is like a what we normally use as a general technique. So let's say you have some numbers, those are very difficult to work with. So like let's say maybe this one. So what we're gonna do, we're gonna use the quadratic formula. Um, and so what's the quadratic formula again? So it is x equal minus b plus or minus b squared minus 4ac square root only of that term, and divide the whole thing by 2a, where we assume that a not equal to 0. So that's the quadratic formula, and that's we normally use as a last resort. We try to use the other technique first, especially the factoring method, and if you cannot do it, then we can go for that. So that's what we learn about about the quadratic equation. And you can find, if you want to know more about these, and you can find the link in the description. So let's more focused on the quadratic function, not the quadratic equation in this one. So let's go to the function again. So what we have is, so we have a function like this, fx equal ax squared plus bx plus c. Again, we assume that a not equal to 0. Let's talk about how to graph them first, like a basic graph situation. So so graph the function. Okay, so that's the first one. So we're gonna see graph the function. What we normally do for these kind of problems, we're gonna use the transformation technique. So we're gonna use transformation techniques. Transformation techniques. So let's look at two problems. Let's say we have fx equal negative 2x squared plus 3. So what we can do, we can use the basic, we can start with basic functions or the parent functions, and then we step by step we're gonna get to the equation. So what we can do, you can see that in this case we can start with y equal x squared. So we can say y equal x squared. So and we know the graph of this function. So this is the parabola. So we have this, and then we can go to the next one. So what we can do in the next step, we can do -2. So -2, you can go in either 2 steps or 1 step. So one is you scale by 2 vertically, and then you multiply by negative, means you can reflect about the x-axis. So you can do it in 2 steps, or you can do it in 1 step. So let's do, just for this problem, let's do it in 2 steps. So let's say next one is y equal negative x squared. That means you're gonna flip the graph about the x-axis, because you can see it is outside. Outside means vertical change, so it's vertically flip over. So that means I'm going to lift the axis just to show the flip. So you can see it's going to flip over the x-axis, so it's going to go like that. So that's what happens when you multiply by the negative sign. And then so then the next step, what we can do is we can scale up. So it's a -2, so you can adjust the scale. So in scale, what happened? you can see every all the coordinates you multiply by 2, so that means every coordinate multiplied by 2, that means you can stretch vertically. So 1 become 2, that's the idea. So that means your new graph looks like that now. So you're gonna get this one, so you're gonna stretch vertically. That means your new graph gonna look like this, stretched. Good. And then the last one is you can see it is the vertical shift. So it is negative 2x squared. You're gonna vertical shift by 3. That means you're gonna move the graph 3 units up. So what's gonna happen? So no change, it just move up. So that means it's gonna move up 3 points. So you're gonna go over there. So that means your new graph gonna look like this. So you can see there are no changes, just move up. So that is the graph just by the transformation technique. So in just 4 transformations or 3, you can combine the middle two, you can get this graph very easily. Don't use the plotting points technique because that's not going to give you the like a good graphs. The reason is we really don't know where the turning point. We don't know the turn. In this case we know, but in general we don't know where the turning point. So that means if you just plot points, we might miss the turning point and we get a wrong graph. So it's a good idea to use the transformation unless you really know the turning point. We can talk about the turning point technique later. Then you can do it, but not just like plug in some values and plot in those points. That's not the right way to do it. So let's look at another problem, just a little difficult. How about this one? So let's say we have um, fx equal negative x minus 3 squared plus 7. Again, we're gonna look at steps here. So there are so we can start with again y equal x squared, the basic graphs, and then either you do the flip vertical flip, or you can move horizontally. So those two steps actually you can interchange, but you can interchange with the vertical one, so you have to be careful with the vertical shift. We normally do the vertical shift at the end. So let's start with the first basic function. So we have y equal x squared, and again we know the shape of this graph. So we have the familiar parabola here. Now you can do either vertical shift or the flip. So let's do the vertical shift. So we have y equal x minus 3 square. That means you can see the graph gonna go 3 units to the right. So we can do that. So those are the axes. No much changes, just move 3 units to the right. So that's gonna go like that and go like this. So that is where the unit 3 is. And then we can do the vertical shift. So the next step we can do the vertical shift, which is y equal negative x minus 3 squared. So you can see this is a vertical change because outside. So that means a vertical change, vertical shift. So plus become minus, minus become plus. So that means I'm going to switch the axis a little bit up. So what's going to happen? It's going to flip over. The point 3 is still at the same place, but it can flip over. So that means your graph going to look like this. So what happened? The graph flip. So what happened? This one flip about the x-axis. Good. And then the last thing what we need to do is the graph gonna move up. So the next one is I'm gonna do it here. So you can see it is y equal negative x minus 3 squared plus 7. That's the easiest one. So it's just gonna move up 7 units. And also we normally at the last step we can find the y-intercept. To find the y-intercept, what we can do, we simply plug in 0. So you can see if you plug in 0, you're gonna get negative. What we have is negative 3 squared plus 7. So which is negative 9 plus c, so you're gonna get negative 2. so which is -2. So that means the graph should cross at -2. That's a y-intercept. So that will be very useful when you do the final drawing here, because we know that even though you lift up by 7 units, um, it's this has a negative y-intercept. So we're going to pass through -2 and go and come back. So that's the shape of the graph. And then we know exactly that's the number 2 and that's the number 3. So so that is a very accurate graph, and also if you plug in 3, and you can see that it is exactly a 7 here, so that's that 7. Good, so this is 3 7. Okay, so those are some accurate graphs. So you can see the transformation give you like a best graph. So we cannot get these kind of graphs using the plotting points technique. Okay, so that's about what we did earlier. So this is just a recall of what we did. Okay, let's try to continue. And then also, if you are not familiar with what we did here, you can look at the transformation video, which you can find the link in the description or in the playlist. Okay, so let's continue with this. So what we're gonna do, we're gonna go to the easiest graph, that means easiest function, because in general we have a, b, c. So let's say we only have a, no b or c. So so we can talk about what we call the concavity. Concavity. Okay, so so let's talk about the concavity. So we can talk about two situations. So we're gonna say concave up or concave down. um, Concave up. This sometimes we call opens up, or and then we have concave down. Concave down, we sometimes call this opens down. Okay, good. So let's talk about these two. So concave up or concave down. So so our general equation is fx equal, let's say we're going to talk about a very special case right now. So we say ax squared, so we do not have b or c. So what the b or c does, b gonna change the graph horizontally, so and then c is going to change the graph vertically. So if you look at the actual graph, actual function, so what it does, so when you have ax squared plus bx plus c, this is going to change the graph horizontally, and this one going to change the graph vertically. So that's what happened if you look at the transformation techniques, and you can see b going to change the graph horizontal, and then c going to change the graph vertical. So here we assume that b or c not there, so it's just a. So what happened, there are two cases to consider, and you notice that this term is always greater than or equal to 0 because it's x squared. Okay, so for any number, either is positive or 0. Now what we can do, we can consider two cases. So we can look at a value of a. So there are two cases to consider. So let's say what if a is positive. So if a is positive, and you can see since x squared is always either positive or 0, all the numbers you get are positive values. So that means if you look at the graph of the function, so what's going to happen, you're going to get a graph going like this. So you only have positive values, you don't have negative values. So these kind of situations are what we call opens up, because the graph goes up, or concave up. So we call this is opens up, or concave up. And then also you can see in this case, there if this is the case, then there's a minimum value. There's a minimum. So if a positive, there's a minimum. Now let's talk about a negative case. If a negative, what happens, since again x squared is either greater than or equal to 0, since a is x squared is greater than or equal to 0 and a is negative, you can see all the values are either negative or 0. So that means the graph going to go backward. So I'm going to flip over. So your graph gonna looks like this now. So that's the shape of the graph. Again, it's again go through 0. So in this case, you can see there's a maximum value now. So there's a maximum, and also in this case, what we call is opens down because it looks like going down. So opens down, or sometimes we call concave down. Concave down. You can talk about more concavity later in calculus, calc 1. But this is the introduction. So what happens if A is positive is concave, like opens up. If A is negative, it opens down. So A positive opens up, A negative opens down. See, it's positive and negative, so it's easy to remember. If A positive, it goes the positive side. If A negative, it goes to the negative side. So easy to remember. Good. So like going like that and going like this. Good. So, so let's do just one example just to see how things gonna work. So we can look at this problem. So let's say graph fx equal 3x squared, gx equal 10x squared, and hx equal half x squared. Let's try to graph all those three in one set of axes just to see the difference. So let's say we have these axes, and I'm going to start with so you can see in the all three cases is 3 is a positive, 10 is a positive, half is positive, all positive. That means a positive, so that means you should have a graph like that, opens up. So I'm going to start with the middle one, so 3x squared. So what is the shape of the 3x squared? um, so let's say 3x squared has this kind of shape. So if 3x squared has this kind of shape, so this is y equal 3x squared. Now the question is, what is the graph of y gx equal 10x squared? But you can see we have 3x squared and 10x squared. When you have 10, you can see the values are you can see about 3.3 times larger than the values of 3x squared. So that means this graph is stretched up. So the shape of the graph are gonna look like this. You can see it's like it's grow fast. So go like that. Okay. So that's the graph. This is y equal, you can say y equal 10x squared. So it's like more. Like for example, if you have 1, you get 3 for the first one, you get 10 for the second one. That's the idea. Okay? You get 10 here, and for the other one you get 3. So you can see that's what happened. Now, and if you look at the other one, which is half, so it's very slow. So that means at 1 you get half, so that means small. So that means graph gonna look like this. So that's the shape of the graph for y equal 1/2 x squared. Okay, so idea is very clear. So let's look at another example, but with negative values now. So you can say again graph fx equal negative 3x squared, gx equal negative 10x squared, and then hx equal negative 1/2 x squared. And you can see in this time all the a values, these are the a values, because all the a values are negative, so that means it's gonna opens down. So it's going like that, it's gonna grow downward. So so as before, so we can look at the shape of the graph. Since they are going down, I'm gonna draw it like that. So you can see if you start with negative 3 again, so you can see it's gonna take a shape like that. So that is y equal negative 3x squared. And then if you look at negative 10, that's more smaller, by stretch downward. So that means the graph gonna go like that, a stretch. So this is y equal negative 10x squared. And then if you look at the last one, you can see that's negative 1/2. This is not this grows slow. We're gonna go like that. So this is y equal negative 1/2 x squared. Okay, so that's very clear. So the a term decides the concavity, and then how fast it's going to grow, and also whether it's open up or open down. Okay, so let's continue with that. So let's look at the most important part of this discussion is what we call the standard form. So let's talk about standard form. Standard form. Standard form. So the rest of the lecture depend on this idea, the standard form. So what is the standard form? What we normally do is we can start with the function, which is fx equal a x squared plus bx plus c, where a not equal to 0. This is like a discussion how you actually derive the formula. So if you can skip this part of the video, and you can look at the description. You can look at the timestamp, and you can jump to the formula directly. But otherwise you can see like how it works. So what we normally do, we use the completing square method. So use the completing square. Use completing square. So when you use a completing square, you can do something interesting. So let's say we start with the function fx equal a x squared plus bx plus c. Again, we assume that a not equal to 0. Since we don't know what is the value of a, if a is 1, the things would be much easier. But let's say in general a not equal to 1. So if a not equal to 1, what we normally do, we're going to factor out a. So if you factor out a, what happens? You divide everything by x, by a. But we normally do that to the first two terms only. So we do that the first two terms only. We write c outside just to make the calculation easier. So if you divide by a, so you get x squared here. Here you get b over a x. So we can leave some space here, plus c. Now what we can do, we can calculate that special term, what we normally call the magic term, which is normally the half of the coefficient of x, that means that, and squared. So that term is b over a, so you can take half, that means b over 2a, and we can square that. So that is that special term you can add and subtract. So it is b squared over, if you from the bottom you get 4a squared. That term you can add and subtract. So it is b squared over 4a squared. But be careful, when you do that, you actually multiplying that term by that, because there's a outside. So that means when you subtract, you are not just subtracting b squared over 4a squared. You have to multiply by a. So because of that, you are actually subtracting minus b squared. When you multiply the b squared of 4 by a, you lose one a term. That means it can be 4a. That's what you subtract. When you add and subtract, that's a subtract. Now we just simplify this. So you can see that because of that special term, this simply become a complete square. That's the whole point why we do that. So this is always half of the coefficient. That means b over 2a always, and then we say square. So it simply become a square. Plus, now what we can do, we're going to simplify that part, the other part. So you can see we can take the common denominator. Common denominator is 4a, so 4a is missing. So that means, so you can see c, so you can say 4a, and then over 4a, and then minus b squared over 4a, and you can see now the common denominator is there. So you can rewrite it like this: a x plus b over 2a squared, and if you simplify this one, you're going to say 4ac minus b squared over 4a. So this is what we call the standard form, but we're going to make a small arrangement. So we're going to say a, we can write this one as x. We normally write with the minus sign. So that means how we do that, we're going to say minus minus, because it's a plus sign, so it's a minus minus b over 2a. That's how we normally write it. And then we have squared plus, we don't do anything here, so 4ac minus b squared 4a. So this is what we normally call the standard form. Why? You can see, you can write this one as so what we normally do, we're gonna pick this part as h. We're gonna call this is h, and we're gonna call this whole term k. So if you do that for the h and k, you can write this one as a x minus h squared plus k. So this is what we call the standard form. And so again, so what is h? So h is simply you can see minus b over 2a. K is simply 4ac minus b squared over 4a. Now there's a question, which one we have to remember? Do we need to remember both? No, we only need to remember this one. You can explain the reason why, because you can see that um, um, what we normally do is we try to make the square term 0. Once you make the square term 0, you get the other term. So in other words, to make the square term 0, we normally plug in this h value to the function. Once you plug in the h value to the function, you can see that the square term go to 0, so you get the value. So that value is exactly the k. So that means you don't need to remember k. K is simply calculated by plugging the f value to the function. So that means this is simply equals to, you can see this is simply equals to f minus b over 2a. So that's what we remember, that's what we're going to use. Okay, so let's go back to the standard form now. So that means you simply, so in a regular problem, what we normally do, you just use the completing square technique. So that's how we do it. So so we can say, so I'm going to rewrite this again. So what happened when h equal minus b over 2a and k which is 4ac minus b squared over 4a, but we show that this is simply 4 minus b over 2a. So that means this is important, and also this is important, that is the k value. So if this is the case, then you can see that you can write your function fx in this form: a x minus h squared plus k. So this is what we call the standard form. So this is the standard form of the quadratic function. Okay, so we call this a standard form. Standard form. Um, so we can talk about a few special cases. So what's going to happen? So let's look at the shape of the graph in those cases. So we can start one by one. We can talk about all those important properties. So the first one is, so let's talk about what happened with a positive and a negative. Uh, so when a is positive, so what happened? So your graph gonna take a format like this. So it's gonna go like that. And when a negative, what's gonna happen? The graph gonna go the other way. So it's gonna go like this. And then this point is what we call the vertex. So this point is called the vertex. You can see that's the either minimum or maximum value depending on the situation. That's the vertex. And you can see that vertex you can simply get, this is the h value that we found, this is the k value that we found over there. So again here is the h value and the k value. So the reason is, when let's say a is positive, if a is positive, you're trying to add something there. So that means if you remove that, you get the minimum value, the k value there. That's why you get a minimum when a is positive, and if a is negative, what happens? You try to subtract something. So if you do not subtract, you get the large value. If you subtract something, you get it smaller. That's why when a negative is gonna go down, we have a maximum. When a is positive, you have a minimum. Okay, so this has a maximum and has a minimum. So this vertex is given by, so in both cases the vertex is given by we normally call it h and k. Those values are simply negative b over 2a, comma, to get the k value, what we do, we're going to plug into the function that value you calculate earlier, minus 2ab. That's going to give the k value. So that is how you get the vertex. And the next one is how to get the axis of symmetry. You can see these are symmetric about this axis. This axis is given by, so what we call the axis of symmetry. Axis of symmetry. So axis of symmetry, which is like x equal k. This is given by x equal, in this case, h, x equal h, or h is equal to negative b over 2a. So that's going to be the axis of symmetry, x equal negative b over 2. Actually, it would be better to write it like that, but that's the x value. That's the h coordinate. If you find the x coordinate, that's simply that value. So you can write it like that. So the vertex and the axis of symmetry. And then there are more properties depending on those two situations. So let's list all of those properties, and this is the only thing you have to remember for any of those problems. Okay? So there are no any other cases. So let's list all of them, A and B. So you can see in the when A positive, there's a minimum, A negative, there's a maximum. So let's list all of them. It is concave up, so it has a minimum. So we have, so let's talk about those two cases again. So we have A positive and the A negative. So when A positive, so there's a minimum. So has a minimum. So it has a minimum, and then has a maximum. So again, remember the shape of the graph, because if A positive, it's going to go like that, so it has a minimum. When A negative, it's going to go like that, so it has a maximum. And then you can see that the both values are the same. So it is f negative b over 2a in both cases. F negative b over 2a. So that's the either maximum or minimum value depending on the situation. Okay, those are the two cases. Depending on that, you're gonna get that. Okay, and then we have increasing and decreasing, and you can see that. It's decreasing. In this case, is decreasing on the interval, you can say negative infinity, all the way up to the h coordinate, all the way up to the h value. So that's the h value, and again that's the h value. So you can see it's going to go all the way up to h. So that's where it's going to decrease. And here what's going to happen is going to increase on the same interval, increasing on negative infinity all the way up to h. And then it's going to increase here, okay, increasing on h to positive infinity, and here decreasing from you can see h to positive infinity. Okay, and then what's the next one? And then we have the domain and the range. So we have the domain. So what's the domain? And you can see that for both cases the domain is negative infinity to positive infinity, because this is a polynomial. So domain is all the real numbers for both cases. It's both cases the same domain. And then the range. So you can see the range would be different. So what's going to happen in this case? The range is, because it's concave up, it's going to go to infinity. So you can see the smallest value that you can get, that's a minimum. The smallest value that can you get is k. So that means so range is going from you can see k to all the way up to positive infinity, and the other one you can see is k all the way go down, because it's a concave down, it's going to negative infinity. So the range in this case is you can say it is going negative infinity all the way up to k value. So that's the range. Domain is the same. And then you can also talk about the zeros or the x-intercept. So what are they? So you can say x-intercept. So what happens if b squared minus 4ac greater than or equal 0? Then you can solve the equation. So the x-intercepts given by x equal negative b plus or minus b squared minus 4ac. So that's going to give you the x-intercept when b squared minus 4ac. But if b squared minus 4ac negative, what's going to happen? There are no x-intercept, no x-intercept. Because what's going to happen in this case? So let's look at the two graphs here. So for the first case, you can see the graph's gonna go like this. One can cross like that, and the other one can like a touch like this. It's gonna go and touch. So there's a 2 or 1. But what happened in the other case? You can see in the other case, there are no x-intercept. That means gonna graph gonna go like this. It's not gonna touch the x-axis. So go like that or go down. So that means like this, like that. So that's what happened in the last case. So those are all the properties of the quadratic function, and we can do several different examples to test how we do a problem like that. But those are all the theories that we need to study. Okay, so let's do some examples. So let's do this problem. What it says that use transformation to graph fx equal 2x squared plus 8x plus 5 and find the vertex and the axis of symmetry. So what we can do, so the answer. So we're going to start with the function and do completing square technique. So which is 2x squared plus 8x plus 5. So you can see that the coefficient of x squared is not 1, so we're going to factor out 2. So we factor out 2, you get x squared plus 4x, and then we have plus 5. Now what we're going to do, we're going to find the special term, so which is the half of the coefficient of x. The coefficient of x is 2, so we're going to take the half of that and a square. You can see that the number is 4, so we're going to add 4. And you can see that when you add 4, it's not really 4, it's you have to multiply that one by 2. So that means you're gonna subtract 2 times 4, which is 8. So so where this is coming from, which is 2 times 4. Why we do that? To match, because you add subtract, so because you make sure they are equal. Okay, now we're gonna simplify. So you can see if you simplify is 2, and this is that special square here, which is always x, half of the coefficient of x, which is 2 squared minus, if you simplify you get minus 3. So that's what you get. This is standard form, but you can write this one with negative sign. So it's 2x minus minus, so minus minus 2 squared minus 3. And then once you do that, so that's a standard form. So standard form. So you can see that in this case h equal, so that's the h and that is k. So that means so h equal -2, k equal -3. That means since you know h and k, we can add the vertex and the axis of symmetry. So the vertex equals -2, -3, and the axis of symmetry, which is x equal the h value, which is -2. Okay, so we know that. Now what we can do is, and we can also know a few things about this one. The a, in this case a, which is 2, you can see this is positive, means that opens up. So this is the concave up, or opens up. So opens up. And then we can graph the rest of the function using the transformation technique, because now we have a, so what we're going to use, I'm going to use this one to graph the function. So you can see this one, if you use this one, it's very easy to graph the function. So let's do that. So we can do step by step here. So again, we can say y equal, we can start y equal x squared, and then we can do y equal 2x squared, and then we can do y equal 2x plus 2 squared, and then finally we're gonna go y equal 2x plus 2 squared minus 3. So if you graph one by one, so that's the first one, and then we do the scaling here, um, and then the shifting, and then scale down. So okay, so let's try to graph one by one. So you can see this is y equal x squared, that's the standard parabola, and then we're going to scale by 2, so you can stretch vertically, so 2 times, and then I'm going to shift, you can see shift to the left by 2. And if you forget how to do this kind of shifting, you look at the transformation video, I explain everything over there. So you're going to move 2 in this way, which is -2. So that means so the graph gonna look like that. And then the next one is what we can do, we can bring this down by 3. But the problem is there's only one issue here. We don't know what is the y-intercept, and you can see to get the y-intercept you can plug in x equals 0, and if you plug in x equals 0, you're gonna get what do you get? If you plug in x equals 0, you can see that it is 2 squared. 2 squared means 4 times 2 means 8 minus 5, so that means it is 5. So that means the graph, when you go down, the graph gonna cross the y-axis at 5. So that means it's gonna go down like that and gonna go like that. So you can see this is 5. So this point is 5, and then here you can see this is -2, and then we move down by 3 units. Okay, so that's the shape of the graph using transformation technique, and it's very easy. After we have the completing square, then it's very easy to use a transformation to get the idea. Okay, so let's look at the next problem. So problem number 2. So it says use the vertex and the axis of symmetry to graph the function. So there's a function given, and they ask you to use the vertex and the axis of symmetry technique, and also asking whether it's open up or down, and what is the domain and the range. Domain is easy because it's a polynomial. Domain is all real numbers, but the range you need to consider whether it's open up and down, and that decides the domain. And also the question is where it is increasing and where it is decreasing. That's also depend on whether it is open up or open down. So let's try to do the problem. So what we're gonna do for a problem like that, if you need the vertex and the axis of symmetry, we can directly use the formula for the vertex, the h value and the k values. So we can use that argument. That's a kind of shortcut here. So what we have is, so the answer. So for this problem, and you can see that a is -3, and the b is 6, and the c equal 1. Those are 3 values we get. So for the vertex, so you can see for the vertex, we're going to get h, which is, by theory, it is -b over 2a. So you can directly use that. So we're going to plug in the values. Is negative, b is 6 over 2 times 3 means -3. And you can see if you simplify, negative get cancelled, is 6 over 6, which is 1. So h value is 1. Now since you know the h value, the easiest way to find the k is, we know that by theory, which is f -b over 2a. Since you already have this value, it is simply f1. Why 1? Because the 1 is the value we calculated already, because we know that the h equal 1. Good. So you plug in 1 here, so it is -3 1 squared plus 6 times 1 plus 1. If you simplify, you will get 4. Good. So that means we know the vertex, which is equals to 1, 4. That's the vertex. And the axis of symmetry, the axis of symmetry, is x equal the h value, which is 1. Okay, so we know the vertex and the axis of symmetry. Now we can use those information to graph the function. But before that, we're going to calculate. We're going to find the answers to ABC, and because that's going to help you to get a better shape of the graph. So let's look at part A. So what's the part A is saying? Whether it's open up or open down, and you can see that in this case A is -3, which is negative. So negative means it is open down. It opens down, or sometimes we call it concave down. Concave down. So you can use one of those words. Concave down is a technical term actually. And then part B. Part B is asking what is the domain. So you can see in this case the domain is simply all real numbers because this is a polynomial. What about the range? So range can be confusing. Range is, so you can see this is concave down. Concave down means it's going to go like that. So if the graph going to go like that, the range means from -infinity all the way up to the k value. So that means it is -infinity to the k value. Since the k value is 4, it's -infinity to 4. Since, because it can reach 4, that means -infinity to 4. Now the other question is whether it is increasing, where it is increasing and where it is decreasing, and you can see it is increasing on the interval from -infinity all the way up to the k value, all the way up to the h value. So h value is 1, so that means 1 including, and decreasing on you can see it's going to decrease from the h value to all the way up to infinity. So those are the answers to those questions. And also we find one more information. We try to find the y-intercept, so because that's going to help you to get like a better graph. y-intercept is simply f0. So if you plug in 0, you're going to get -3, which is 0 squared, and 6 times 0 plus 1, which is 1. So using this information, we can graph the function now. So we have those axes, and then we also know the vertex, which is 1 and 4. That's a vertex. And also we know the y-intercept. Y-intercept was 0, 1, 0, and 1. So that's the y-intercept. So by symmetry, and you know that the axis of symmetry is x equal 1. So that's the axis of symmetry. What the axis of symmetry means, that means the graph is symmetric about this point. So that means at 2 also you should get 1. So that's the value 1. You should get the exact same value even at 2. Because that's going to give you the by the axis of symmetry. So that means since we know those 3 points, we can have a neat graph here. So that means graph gonna go look like this and passes through this point. So that is the shape of the graph, and this is the axis of symmetry, and that's the vertex, which is 1, 4. So which has the maximum value at 4. So that's the shape of the graph, and using all those facts. Okay, so and if you need this point, this is 2, 1. This is 0, 1. That's the y-intercept. So you can always use the y-intercept and reflect it back to the other side to get the other point. So that's a kind of idea we can use. Okay, let's do another problem. Um, so how about this one? So the problem says rewrite in the standard form fx equal negative 3/4 x squared plus 1/2 x plus 5 and find the vertex and the range. So you have to find the range also. So if you get a problem like that, you can normally do a problem like that in two different ways. One is the use the completing square technique. We directly use the completing square. The other method is, since we know the formula for the vertex, the x coordinate and the y coordinate, we can simply use those two to get them. So let's do this in both ways. So let's do the method one. So method one is just simply use the completing square technique. So we're going to start with fx, so which is negative 3/4 x squared plus 1/2 x plus 5. So we're going to pull out 3/4, that is the x square, the coefficient of x squared. So we get x squared. That means we have to divide the second term by that. So how to do that? So that means we have 1/2. So we can divide 1/2. So divide means you multiply by the opposite one, reciprocals. That means 4/3. You can take care of the negative sign. So that means if you do that, you're going to get 2/3. So that's what happens when you divide by 3/4. You multiply by the reciprocal. So that means with the sign, you can see that this is simply a negative 2/3 x, and then we leave a space plus 5. Then we need to find the next term. What's the next term? We take the half of this and square that. So we take the half of the coefficient of x. So that's the coefficient of x. So we can take half of that. So which is, you can disregard negative sign because we're going to square, but if you want, you can write everything. And we're going to half it and square. So you can see when you take half, 2 and 2 get cancelled. So you simply end up getting negative 1/3. We can square that. So which is 1/9. So that is the term we can add. So negative 3/4 x. Oh, actually, yeah, we can add that term here. So which is 1/9. Now, so you cannot just add. You have to add and subtract. But you be careful when you add 1/9. The outside of that we have this this term. So that means you have to multiply those two and add the opposite term. So that means when you multiply negative 3/4 with 1/2, you're gonna get 1/12. So that means, but this is negative. That means you're gonna get add 1/12. So where this is coming from? So this is simply you can see. So you multiply 3/4 times 1/9. So which is going to give you 1/12, but the opposite sign because you get a negative, so that means it's positive. Okay, so we have everything here. Now this is x minus the half of the x coefficient, that means 1/3 squared, plus if you simplify this one, this is very easy to simplify, and you're going to multiply these two and then add that. So if you do that, you're going to get 61, so which is 61 divided by 12. So that is in the standard form now. So you can see, so that is the h term, so which is equal to h, and that is the k, so this is equal to k, and also this is in standard form. Okay. So standard, so we have standard form. Good. So we can write everything we need. So we can write the vertex, which is 1/3, 61/12. You can see, you can simplify that further. And then that's a vertex. What is asking? It also asking the axis of symmetry. So the axis of symmetry, which is x equal the x coordinate of the vertex, which is 1/3. Okay, it's also asking the range, but before we find the range, we need to make sure check whether this is open up, open down, and you can see a equal negative 3/4, which is negative. That means going down. So that means opens down. So opens down. That means the range has to be, because since it's going down from negative infinity all the way up to the k value. So that means which is negative infinity 61/12. So that is the range. Good. And then we can also graph this function, but I'm going to show you the other method to find the vertex without doing the completing square technique. So let's look at that. So let's do. So in method 2, we directly use a formula. So the method 2, we know that h is simply negative b over 2a. So we're going to plug in the values. We know that the a is negative 3/4, b is 1/2, and the c is 5. We don't need c for this. So we're going to plug in the value. So which is negative, b is 1/2 divided by 2 times negative 3/4. And how to simplify something like that? You can simplify the bottom first. You can see we have 2 and 1/4, so you can simplify that. So you're gonna get 3 halves, and also you can simplify the negative sign, so we don't have that anymore. So that means you're gonna get 1/3 here. Good. And then to find the k value, what we're gonna do, we're gonna go to f negative b over 2a, which is simply the h value. So that means f 1/3. So you're going to plug in the 1/3 into the function. So you're going to get negative 3/4 1/3 squared plus 1/2 1/3 plus 5, and this simplifies to negative 1/12 1/6 plus 5, and you can see this end up being 61/12. Good. So that is the other way to get it, like, thus we just use the formula directly. So what's the formula again? H is simply given by that, k is simply given by this. Good. Now since we know the vertex and the axial symmetry, and also it's always easy to find the y-intercept. So y-intercept is simply f0. If you plug in 0, you get the constant term, that means 5. Using these facts, now we can simply graph the function. So what we have is, so the vertex is at 1/3, 1/3, 61/12. That's just a little over 5. So so this is the value 61/12, and then we also know the y-intercept, which was 5. So now we can graph the function that has to go through these values. So that is the graph of the function or parabola. Good. So let's do another problem. So let's try to find the quadratic function given the vertex and the another point. So maybe another point, maybe like special point, or like a y-intercept or some other general point. So let's do this problem. So what it says that find the parabola whose vertex is -5, -1, 5, and the y-intercept is 2. So what we're going to do, since we know the vertex, we can actually write the format of the function. So the answer, since we know the vertex, so the so you can see vertex is -1, 5, So that means h has to be -1 and the k has to be 5. So then we can actually write the formula. So we know that the fx is simply a times x minus h squared plus k. So we can plug in those two values. Only thing that we don't know is a. We can plug in x minus h is -1, so minus 1 plus k is 5. So that means which is a x squared, a x plus 1 squared plus 5. But we also know that the y-intercept is 2. Y-intercept means f0. So since you can say since the y-intercept is in this case it was 2 or -2. Yeah, since the y-intercept is 2, you can say f0 equal 2. So we're gonna do that now. So we're gonna plug in that to the function and try to find a. So we can say so because of that is a 2 equal a that we don't know, and then we have 0 plus 1 squared. Why 0? Because of y-intercept plus 5. So this says 2 equal a because 1 squared is 1, so plus 5. This can give you a equal -3. So that's the a value. Then we're gonna go back and plug in that. So it is fx equal -3 x plus 1 squared plus 5. If you simplify, which is -3, you're gonna get x squared plus 2x plus 1 plus 5. So if you simplify, you're gonna get -3x squared minus 6x plus 2. Good. So that is the function we are looking for. Okay, so let's try to do one last problem. This is just exaggeration because one of these is like one of the great application of this idea, the maximum and minimum values. So maximum and the minimum values. So what we can do, we can use the vertex argument. So we know that for a parabola, let's recall what we did for the parabola. We know that for the parabola fx equal a x squared plus bx plus c. So we have the vertex is at negative b over 2a f negative b over 2a. So that means the k value, which is the function evaluated at negative b over 2a. So what happened is going to be a minimum if a is positive. That means the shape of the graph is like this, and then has a maximum if a is negative, so which has a graph like that. So that's the idea we're going to use. So that means just the k value, is the maximum minimum. So let's just do just one example from this. So let's do this problem. So it says does fx equal -x squared plus 4x plus 5 has a maximum or minimum? So we'll figure out whether this has a maximum or minimum, and then what is that value. So how to do a problem like that? We need to figure out the answer. So not that in this case a equal -1, b equal 4 and c equal 5, and you can see that a which is -1, which is negative. Negative means it opens down, so that means opens down. That implies that has a maximum. Has a maximum. And then the maximum is at the vertex. Maximum is at the vertex. Okay, so that means to find that value, what we can do, so that means the again I'm repeating that, so the going like that. What we normally do, we find the h value first, so it is negative b over 2a. If you plug in, you get negative, and then b is 4 plus 2 times negative 1. So if you simplify, you get 2. That's it, h value. So now what we can do, the maximum is the function value at that point. So the maximum, so maximum value is simply f f negative b over 2a, so which is f2. So if you plug in 2 to the function, you get negative 2 squared plus 4 times 2 plus 5, you end up getting 9. So 9 is the maximum value. So so which is 9. Okay, good. So that is the end of the video. Thank you.